Welcome back to Module 3, Fundamentals of Blockchain and Distributed Ledger Technology. In this lecture, we will discuss about Lecture 3.3, which is related to blockchain components and characteristics. In this lecture, we will explore blockchain, blockchain components, and blockchain characteristics, which are making it a disruptive technology. We will also explore blockchain-based applications, which we call decentralized applications, as well as we will explore different blockchain use cases. According to CHAISE learning outcomes, after this lecture, you will be able to explain what are the blockchain components and the characteristics. You will also be able to explain what are blockchain-based applications and different use cases. So, the mainly learning objectives of this lecture are related to blockchain, where we will explore blockchain components and characteristics. We will explore blockchain-based applications and their design patterns. We will also explore blockchain usage, where we will briefly discuss Web3 and the myths about blockchain which are currently circulating in the blockchain in the market. So, let us get started. Blockchain, once you hear about blockchain, what comes in your mind? It comes like it is a decentralized, distributed and immutable ledger technology. It is immutable because it cannot let you edit or delete something, but you can only add or append the data in the mutable ledger. So, that is why it is called a mutable ledger. Blockchain operates over peer-to-peer network and distributes a ledger every time on an entire peer-to-peer network when a new block or transaction occurs. A ledger contains a certain and verifiable record of every single transaction ever made. Blockchain eliminates trusted third parties in a transactional process and records transaction in a decentralized and distributed ledger. A blockchain ledger is a chain of blocks where each block connects to a previous block by a unique cryptographic hash. The first block in a blockchain is called Genesis block, and every block has a header and a body, which is called block configurations or block settings. If you go to block explorers, then you can find the first block in the Bitcoin blockchain, and you will see that it was created 14 years ago and it has only one transaction which belongs to the reward 50 Bitcoins. Block header includes a unique block hash, a previous block hash which connects different blocks. It includes Merkle root, block version, nonce. Nonce is a number ones, it is a unique random number, timestamp and difficulty target. All these settings you can explore in the block explorer. The block body contains a valid list of transactions that are hashed and ordered as a Merkle tree. So, now let us explore what are different blockchain components and why these components are making blockchain a disruptive technology. So, first is consensus mechanism. So, consensus mechanism a core part of blockchain. Blockchain uses a decentralized consensus mechanism in order to maintain the state and immutability of the ledger. Consensus add a new block once miners solve the cryptographic puzzle, create a fault-tolerant environment and solve a double spending problems in digital currency. Bitcoin uses proof-of-work consensus mechanism, which is a computationally rich and energy-based consensus strategy, where special nodes called miners define the state of the ledger by solving the complex cryptographic puzzles. In contrast, there is another consensus mechanism which we call proof of stake. As compared to proof of work, proof of stake is an energy efficient consensus mechanism where miners, we can say, like become validators and lock a certain amount of cryptocurrency to participate in the consensus process. The blockchain platforms like Ethereum, NXT and PeerChain are using proof of stake consensus. Hyperledger Fabric, there is another blockchain which is a permissioned blockchain. It uses practical Byzantine fault tolerance algorithm. And this PBFT or practical Byzantine fault tolerant consensus mechanism is not energy waste consensus mechanism because it does not require any mining equipment, and it is an effective consensus mechanism for high throughput transactions. There exist other consensus mechanisms, for example, delegated proof of stake, proof of authority, proof of reputation, proof of space-time, and new consensus mechanisms are appearing. These consensus mechanisms are fault tolerant and achieve mutual agreement on a single state of the distributed ledger. Next are nodes. Blockchain nodes are network stakeholders. They are distributed and they come from all over the world and form a blockchain infrastructure or blockchain network. For example, nodes are permitted to maintain the distributed ledger and act as both client and server over a peer-to-peer network. As previously we said, blockchain operates on a peer-to-peer network, and this peer-to-peer network is formed by the nodes. So, node's primary objective is to check if a block of transactions is valid or not and accept or reject it based on the validity. If it is valid, then it is accepted. If it is not valid, then the nodes are going to reject the block, or we can say the transaction which is performed by the user. Corresponding to a node in Ethereum that runs the Ethereum client software and it is connected to other nodes on the network. Nodes are connected on a peer-to-peer network and serve as communication hubs for various network operations. Connected nodes regularly communicate the most recent blockchain data with one another, ensuring that all nodes are up to date. Nodes store data in the form of distributed ledger, share the ledger with other connected nodes, and execute a consensus process to maintain the ledger and ledger data. Such as these characteristics make nodes an essential tool in blockchain for preserving transaction history. Various kinds of nodes have a specific job to perform within blockchain networks. For example, full nodes store and maintain the full blockchain data and serve blockchain data upon request. Also, full nodes help the blockchain by participating in block validation and verifying blocks and states. All states can be derived from full nodes. In contrast, validated nodes perform transaction validation before processing the transaction further or sending to the miner. And the miners solve the cryptographic puzzle to find the next block within the blockchain. So, here we can see that there are different jobs for validation nodes and the miner nodes. There are another kind of nodes, archive nodes, that inherit the same characteristics as full nodes and create a history of states. Archive nodes are useful when querying historical blockchain data that is not accessible on full nodes. Archive nodes aren't required to participate in block validation and can be built from scratch using a full node. There is another concept is emerging, which includes light nodes or lightning nodes. These lightning nodes are used within lightning blockchain networks or to make transaction faster. The lightning blockchain concept is where you have a small number of blocks in the section of blockchain, and then you are performing the transaction faster as compared to performing the transaction on the full blockchain network. So, another core concept of blockchain is smart contracts. The advent of smart contracts introduces value exchange in peer-to-peer and decentralized manners. Once Bitcoin came, at that time it was only performing the financial transactions, we can say like cryptocurrency or digital currency transactions. But with the smart contracts, we can write autonomous computer programs which are written in a Turing complete programming languages. For instance, Solidity, and this Solidity programming language emerged with Ethereum platform. But we can also use Go language, Java, C++, Node.js, and even you can use JavaScript as well. The smart contracts constitute a digital contract in blockchain to store data and execute automatically when certain conditions are met in the blockchain network. For example, an agreement between buyer and a seller is directly written into lines of codes that can bring trust to the system. It can bring transparency and the security in the transaction. Smart contracts are decentralized because they are deployed on blockchain networks. And as we previously discussed, blockchain networks are decentralized and distributed. Also, we discussed the blockchains are immutable, or they support the immutability. So, it means the smart contracts which are deployed on blockchain, they are immutable and create irreversible trackable transactions. Ethereum platform provides Solidity programming language, a statically typed programming language used to create smart contracts that execute on Ethereum virtual machine to build decentralized applications. In Hyperledger Fabric, the smart contracts are known as chain codes and perform the similar actions according to the coded terms in the contract. Similarly, other blockchain platforms like Corda, EOS, Stellar have smart contracts to reach contractual agreement in the digital realm. Blockchain eliminates trusted third parties in a transactional process and records transaction in a decentralized, distributed and immutable ledger. A blockchain ledger is a chain of blocks where each block connects to a previous block by a unique cryptographic hash. A ledger is replicated, shared and synchronized over a peer-to-peer network within connected nodes. A ledger maintains a history of all the transactions performed and overcomes single point failure like traditional relational databases, which are dependent systems on the centralized services or servers. Moreover, a ledger overcomes the complexity of maintaining data. Many times we have already spoken about peer-to-peer network. So, the peer-to-peer networks are distributed architecture in which peers or nodes share jobs or workloads. Within blockchain networks, the same notion is applied. Regardless of the location of nodes, the linked nodes have similar permissions and responsibilities for data processing. So, we can say that the nodes, the distributed nodes which are on the blockchain network, they have the same power to perform the transaction or to perform the other operations as compared to the other nodes on the network. To keep the blockchain running, network nodes share their resources. For example, nodes share their computer processing power, disk, storage, network bandwidth, and so on. Peer-to-peer network applications do not require a dedicated centralized server or hosts. Nodes operates as both clients and servers, allowing activities to be carried out without the need for a centralized server or governing organization to manage server resources. Cryptography. Cryptography in blockchain plays an important role. As discussed earlier, it is an integral part of the blockchain. Blockchain technology involves cryptography for wallets that hold crypto assets and keys, for transactions that contain information related to the sender, receiver, amount and other necessary details. Security, for example, protects operations and data against malicious attackers. Cryptography also provides privacy, for instance, privacy preserving to protect against privacy leakage. Cryptography within the blockchain protects digital data and enables secure communication while protecting confidentiality, integrity, and availability of data, operations, and resources. Also, cryptography ensures data authenticity and works against repudiation. Blockchain includes various cryptography based mechanisms. For example, secret key cryptography. For example, symmetric key cryptography like advanced encryption standard AES or Caesar cipher. Public key cryptography, for example, asymmetric cryptography like elliptic curve cryptography. Hashing functions that generate irreversible one-way hash strings, for example, SHA and MD5. So, as we can see that cryptography is an integral part of blockchain network because cryptography helps to validate transaction integrity. Cryptography is also involved when generating crypto puzzles that miners try to solve when reaching a consensus. Incorporating cryptography in blockchain protects against various attacks and risks as well, such as sensitive information leakage, privacy protection, data modification risks, and so on. Cryptoeconomics within blockchain is an interesting concept that enables a combination of cryptography and economics, also known as game theory. Cryptoeconomics enables the feature that funds who benefit or protect the blockchain network. For example, data validators, miners, and full nodes, they are building the blockchain network, they are providing their resources so they can get the benefit from the blockchain as well. But in the cryptoeconomics concept, there are punishments who hurt the blockchain network. For example, if some node is performing invalid operations, then the system can take their staked crypto assets or mining incentives or blocking them from participating in the network. So, according to the Ethereum developer Vlad Zemfir, cryptoeconomics combines the protocols that govern the production, distribution, and consumption of resources in a decentralized digital economy. So, cryptoeconomics is a frequently used concept for cryptocurrency to foster trust and keep the nodes honest within the blockchain network. Crypto mining is a process in which blockchains are verified and added to the blockchain immutable ledger. Mining usually follows permissionless blockchains and mostly known as cryptocurrency mining. For example, like Bitcoin mining, and before proof of stake there was Ether mining once Ethereum was using proof of work. But lately they moved to proof of stake, so there is no mining concept left in the Ethereum blockchain. Mining is run by miner nodes. As we previously discussed, there are various type of nodes: miner nodes, full nodes, validator nodes, and all of them have their different jobs. So, miner nodes perform the crypto mining. So, these miner nodes follow the cryptoeconomics concept and solve the cryptography puzzle to find the block and maintain the state of the ledger. A nonce is an abbreviation for number only once, a number added to a hashed or encrypted block in a blockchain that blockchain miners are solving to receive the block reward. Miners are using mining equipment to run mining. For instance, there are different specialized mining machines to perform the crypto mining. Bitcoin uses mining based proof of work. Ethereum switched to proof of stake, and Hyperledger Fabric incorporates practical Byzantine fault tolerance consensus mechanism, which does not require any crypto mining. Proof of work requires huge amount of energy because the miners have to run a specialized mining machines to solve cryptographic puzzle. And these machines needed electricity to run. In contrast, proof of stake gives mining power based on the percentage of coins held by a validator. So, in proof of stake, similarly to practical Byzantine fault tolerance, there is no mining required. So, I was speaking about the specialized mining equipment. So, this mining equipment is a hardware, a specialized hardware designed specially to run algorithm or to programs to solve complex cryptographic puzzles. These mining machines are designed with high performance computation or hash computing power to discover the next block to be appeared on the ledger. For instance, when a miner or pool of miners discover a block, they are rewarded with cryptocurrency such as Bitcoin. Because these machines consume a large amount of power, Ethereum transitioned to proof of stake consensus, which does not need mining or specific mining equipment. Crypto wallets. Crypto wallets within blockchain brought the concept to store private keys and made available to the users once needed. Additionally, you may use crypto wallets to send, receive or spend cryptocurrencies. It depends on the crypto wallet functionality or the features they are providing. Different crypto wallets have different features. There are several different type of wallets available. For instance, paper wallet, hardware wallet and software wallets. Paper wallets are considered the most secure wallets because they do not connect to the internet. After paper wallets, the hardware wallets are considered most secure wallets. Hardware wallets give you the more features as compared to the paper wallets. For instance, some hardware wallets can enable you to send, spend or receive cryptocurrencies directly from their crypto wallets. And the software wallets are called hot wallets, where you shared your private and public keys to third parties. For instance, there are various cryptocurrency exchanges like Binance, Coinbase, Kraken, where you have your cryptocurrencies. It means those cryptocurrencies keys, for instance like private and public keys, are holding by the company which is providing the wallet. So, now we will discuss different blockchain characteristics. These blockchain characteristics are making blockchain a disruptive technology into various industry applications like supply chain, finance, banking and healthcare. So, let us explore one by one what are the characteristics, what are those characteristics of blockchain. So, first is immutability or immutable characteristics of blockchain. We have already discussed several times once we were speaking about immutable ledger, but let us dig deeper to explore what this characteristics brings to the blockchain. So, immutability is an important aspect that contributes to making blockchain secure. For example, blockchain allows only the append-only transactions saved in a block as a Merkle tree, and blocks connect with the previous block in a linked list style with a unique cryptographic hash. So, once the transaction is added to the ledger, the user cannot modify or delete it. For example, the blockchain ledger cannot change or tamper over time, enabling a permanent and unalterable history of performed transactions. Every block connects to a previous block by a unique cryptographic hash, and a minor change can invalidate the ledger. This immutable transaction history is impossible to manipulate, replace, or falsify for stored transactions. Smart contracts are deployed in a blockchain network, and those are also immutable. For example, the developers or any other stakeholder cannot change them once the smart contracts are deployed. Distribution are distributed. We explored blockchain is a distributed which operates on peer-to-peer network. So, the distribution characteristic of blockchain is combined with nodes that comes from all over the world, and the distributed nature and resource distribution of blockchain is a key feature for processing and disseminating data among several connected nodes. The peer-to-peer network sports the distributed ledger, decentralized nature, and cryptographic audit trails of blockchain. Next is decentralized characteristic. So, power is dispersed away from centralized authority in decentralized environment when there is no centralized authority to govern system operations. Every connected node in a decentralized environment shares the same distributed ledger and makes decentralized decision without the need for trusted third party to settle the transaction. Such an atmosphere diminishes trust, since no one has to know or trust anybody or bring the transparency to the system. Furthermore, in a decentralized system like blockchain, resources are owned and shared by network members, nodes. So, there is no centralized authority who is governing the network or who is managing the resources of the system. So, resources are owned and shared by the network nodes, which optimize resource allocation and enhances data reconciliation. Tamper evident. Tamper evident, also known as tamper proof. Blockchain is designed in a way to prevent data, or in our cases like we are speaking about the transactions. So, to prevent the transactions or transaction data from tampering or alteration. For example, the system will detect and discard unauthorized changes if any data tampering happens during the consensus stage. So, such characteristics of blockchain creates protection of distributed ledger against malicious activities, malicious attackers. Moreover, the confirmed transactions cannot be modified. This we can say like if more than half of the network nodes stay honest, then you cannot modify the transaction. But this concept of modification or the attack of tampering attack on blockchain, we will discuss in the later lectures. For example, in blockchain, if a minor change happens, the whole blockchain ledger will be invalidated, because the blockchain ledger is connected with a unique cryptographic hash, and this unique cryptographic hash has a hash of the previous block as well. So, for instance, if attacker is invalidating or corrupting the hash of one block, the subsequent blocks, the previous all blocks will become invalidated. So, this characteristics is providing the tamper evidence, the tamper proof, and this tamper evidence is supported by distribution, decentralization, and consensus within blockchain networks. Another interesting characteristic or concept which blockchain brought us is a provenance. So, provenance provides the auditable and traceable ledger that enables to trace of the place of origin of a transaction. For instance, the transaction was occur, then there was some another transactions. So, if someone want to trace who was the first person or who from which source that this particular transaction was originated, By using blockchain, we can track them. So, provenance ensures the record of ownership and keep validated history of ownership. We can take, there is a famous example of diamond market where the ownership is the utmost important. So, the blockchain can provide the provenance. It means the record of ownership to the diamond. Also, it enables a transaction tracking mechanism where every single change made is trackable. For instance, if someone is going to make changes in the different transactions or performing different transactions, the company or the person can track who performed the transactions over time. With provenance characteristics, we can determine the ledger legitimacy that enables a single source of truth. It means with the provenance, we can overcoming the issue of non-repudiation. Blockchains are pseudonymous. So, one important thing to remember here, blockchains are not anonymous, they are pseudonymous. It means blockchain is not, or blockchain transactions are not directly relevant to your identifiable information like your ID cards, your emails, your bank details. So, these are just related to one cryptographic keys, public private cryptography as we discussed previously. So, still those public and private keys are in your possession, but nobody can identify behind those private public keys. So, that is why we call blockchain as a pseudonymous, but still those transactions are traceable, which we will also discuss this thing in the upcoming lectures. So, blockchain supports the obfuscation of real identity where personal details are hidden and identity and activities are connected to a unique cryptographic hash. So, this characteristics also enhances the privacy. For example, the identity of individual who is performing the transaction remain unknown. Now, we will move towards blockchain based applications, usually known as blockchain based decentralized applications or simply dApps or decentralized applications. These applications can be from supply chain, from cryptocurrency, from finance, healthcare and many other use cases. So, let us explore what are decentralized or blockchain based applications and how they are becoming apparent in different applications domains. So, decentralized applications are digital applications or programs that exist and run on blockchain and peer-to-peer network. Moreover, various off-chain parts, for example, web, mobile interface, machine interfaces and other operating components of application can become the parts of decentralized applications, which utilize the program and the data that exist and run on a blockchain. There are various examples of decentralized applications. For example, we have already discussed cryptocurrencies like Bitcoin and Ethereum to initial coin offerings, non-fungible tokens, for example, like NFTs, which we call. And blockchain based these NFTs are blockchain based cryptographic assets having unique identification code and information that separate them from one another and cannot be traded or swapped as per with cryptocurrencies, like how we usually exchange the cryptocurrencies on the blockchain network. The decentralized applications are used in healthcare to secure medical data. It is also used for personal identity security and supply chain, logistics monitoring, decentralized finance, DeFi. They are becoming important concepts within blockchain that empower blockchain-based infrastructure and open source software to develop all types of financial services. So, this concept constitutes in the DeFi term. Also, the decentralized applications are emerged, or we can say like apparent in centralized finance (CeFi), where centralized corporations and organizations that keep their assets to deliver a variety of services. So, all these concepts, all these applications or use cases are becoming popular or already working in the context of decentralized applications. So, these decentralized applications follow some design patterns, some patterns that aid the developers to develop the blockchain applications easier, or we can say like in the faster way, in the secure way, and in the more efficient way while using the resources for building decentralized applications. So, the first concept here I want to discuss belongs to oracles. Oracles are the most important concepts, two different entities, for example, like on-chain world, which we call like blockchain infrastructure, and off-chain, where blockchain is not involved, it is just like some centralized application or some centralized storage or server. They have to communicate with each other. Then we use oracle. So, oracles are required for blockchain to interface with outside world, for example, like the blockchain applications communicating with the external or off-chain applications for executing some certain activities or operations. Blockchain provides data management and security through tokenization, encryption, state channels, and on and off-chain data storages. When entering the network or engaging in such activities, many blockchain utilizes authorization and X confirmations. These X confirmations are the block confirmations, are the blocks which should be appended or which should be required before making the transaction available for spending again, or finalizing the transaction which is executed. For example, like Bitcoin is using 6 confirmation, and similarly other blockchains are using different number of block confirmations once the transaction is finally delivered or received, and then you can spend further. So, as previously said, blockchain uses the notion of cryptoeconomics to keep their nodes honest by sharing incentives. Furthermore, smart contracts contain agreements between several parties and set their rights and access controls. So, these are some patterns which are used within the smart contracts, and to keep focus on to make the nodes honest on the blockchain network and to perform transactions in the secure and decentralized manners. As we said, like blockchain is becoming apparent, it's emerging in different applications domains. But blockchain is also the concept which is not required for all type of applications. Maybe there is some specific use cases where you need blockchain. So, what are those characteristics? What are those decision trees or decision models on which we decide when to use blockchain and when to not use blockchain, or for what application we have to use blockchain, or for what application we don't have to use blockchain. So, to learn about these things, let us look into this iterative diagram or the chart, which help us to refine or which help us to tell when to use blockchain and when to not use blockchain, or what type of blockchain you have to use. So, this research paper is quite interesting, which has a title, "Do you need a blockchain?" And it has different parameters to look into and then to make decision on to use blockchain or not to use blockchain, or when to or what type of blockchain to use. So, blockchain is being recognized as a technical breakthrough that has the potential to alter how society trades and communicates. And this framework which I am showing to you aids in determining whether the blockchain is the best technological solution for a certain application scenario or not. The same framework helps us to distinguish and contrast the attributes of permissionless, for example, like Ethereum or Bitcoin blockchain, and permission blockchain like Hyperledger Fabric and Corda, and private blockchains like multi-chain. So, the framework provides a systematic understanding, a technique for determining the best technological solution to a specific application problem. Here I have to clarify one thing, like the term permission blockchain refer to the blockchain network that allows only predefined nodes to participate in the consensus mechanism. So, permission blockchains are faster as compared to the permissionless blockchains in terms of transaction throughput and privacy, and they are like more privacy oriented, like we spoke about Hyperledger Fabric. And the same concepts of predefined nodes followed by private permission blockchains, but they have more permission settings or access control mechanisms on different nodes who are participating in the blockchain. So, for instance, if the first question in this framework is like, do you need to store a state? So, if the answer is no, then you do not have to use blockchain. But if you want to store a state, the state which you want like in a future to use to identify what happened with this particular transaction or the asset on which you are performing the transaction, or you are storing the state. So, let us say like you have to the state is important for you for that performed action. So, in that case the next question is like, are there multiple writers? If it is no, then of course you do not have to use blockchain, because you know who is participating, or only you are participating in the block in that application. So, in that case you do not have to use blockchain. But if it's multiple writers are there, then maybe there are some writers on which you cannot trust them. So, the next question is like, can you always use an online trusted third party? If the question is like yes, then again you do not have to use blockchain, because we discussed blockchain is decentralized distributed entity or network that helps to build decentralized applications which are completely removing or diminishing the trusted third parties, the intermediaries from the transaction process. But if you are bringing them, then of course you do not have to use blockchain. You can use some like traditional centralized applications or centralized approaches. But if the answer is no, then the next question is like, are all writers known? If no, then you can use Ethereum blockchain, which is a permissionless blockchain. If the answer is yes, then there is another question, are all writers are trusted? If the question is like yes, so then it means like you know all the participants who are performing or who are involved in the application or in the system, then you do not have to use blockchain. Then you can use like the centralized systems. But if the answer is no, then the next question is like, is public verifiability required? And if the answer is yes, then you can use Hyperledger Fabric, and if not, then you can use the multi-chain or private permission blockchain. So, this question here is like the last question is public verifiability is required. It means the transaction which is performed, does it require a verification and validation or consensus before storing on the ledger or not? If yes, then of course like you need permissioned blockchain where some permission nodes are going to perform this consensus mechanism. But if this public verifiability is not required, you can use private permission blockchain where is one single authority, it is acting as a verifier in the decentralized environment, for instance like in the multi-chain concept. So, there is one very interesting video which was published in 1999. It is related to e-cash prediction, where Milton Friedman is speaking about the e-cash. So I would recommend you to watch this video. It is quite interesting, and it was published before the Bitcoin, so like almost like 10 years before the Bitcoin emergence. So he is explaining exactly the same concept which after 10 years Satoshi Nakamoto brought in the name of like Bitcoin, or in the context of Bitcoin cryptocurrency. I will give like a brief overview about Web3 technology or Web3 in the blockchain context, because this topic is currently emerging, and various organizations are moving their operations, are moving their research towards Web3 or decentralized governance and decentralized technology. For instance, like we are also seeing now there is a lot of concepts which are emerging in the metaverse. So all these concepts are related to blockchain 4.0, or we can say like these are the concepts which are becoming apparent and becoming more and more advanced in the blockchain domain. So Web3, so this is the evolution of web technologies. Currently we have like this centralized web or Web 2, or where for example like this the Web3 notion which is used for a new version of the World Wide Web that integrates decentralization, blockchain technology, and token-based economics like tokenization and other stuff which comes under the Web3. And the concept is to not introduce any central authorities, those to control the application or to control the web. So it means like a decentralized web that can increase data security, scalability, and privacy for users. But yeah, this concept is like becoming emerging, and you can explore more in detail. So yes, there are different blockchain use cases. So again, I have added here one video which brings the concept of blockchain using for provenance in the drug distribution, a drug market, like reaching from manufacturing to the consumer. So it is taking all the traceability and providing the traceability in decentralized and distributed manners to keep the drug which is manufactured in one company, it is actually delivered to the consumer. So it is not like falsified, it is not counterfeited, that drug. So there are other variety of use cases within blockchain and decentralized applications. Not only Bitcoin and cryptocurrencies exchange, but you can now use blockchain for healthcare, supply chain, retail, fintech, Internet of Things, and the list is goes on. For example, I am speaking about metaverse, Web3, and decentralized governance. So you can see that like blockchain use cases are advancing, not only towards not around the Bitcoin or the cryptocurrencies. So there are some interesting myths which are currently circulating in the market. Either these myths are appeared because someone want to sell their idea related to blockchain, or some company want to sell their product by using the different like buzzwords or terms, which becomes a myth about blockchain. So for example, like the first one is like many people say like Bitcoin is a blockchain, but as we learned, Bitcoin is a cryptocurrency and the first implementation of blockchain. So Bitcoin is not a blockchain, Bitcoin is a cryptocurrency, and as well as the first implementation of blockchain, which brought the concept of blockchain. So we can't say like Bitcoin is a blockchain. Blockchain is a technology and Bitcoin is the first application. And another one is blockchain can only be used to power cryptocurrencies like Bitcoin. So I have already showed you different use cases. decentralized application domains where researchers and developers are building different applications in the healthcare, IoT, fintech, supply chain. So blockchain is not only now revolving around the cryptocurrencies. Blockchain is a magical database in the cloud. So again, this concept is completely wrong. Blockchain is not like a database in the cloud. It is a mutable ledger that exists on the blockchain network itself. All information on the blockchain is public. Again, it is wrong if, for instance, like we are using permissioned blockchains or private blockchains, then the information or the transaction details or the data of the users is completely hidden from the public. Only in permissionless blockchains you can share the transaction details publicly, but again in public blockchains or permissionless blockchains, there are different mechanisms to encrypt the information which should be hidden from the public or to get known by others. Blockchain is going to change the world. To some context it is true, but still it needs quite research. For instance, like the current applications which are building on blockchain, they are either in proof of concepts or in the initial phases. So more advanced use cases are needed to fully satisfy this this statement. Another one is blockchain is free. So if we're speaking about permissionless blockchains, you have to pay the transaction fee. Also, it in Ethereum it's called like a gas fee to perform the transaction or to execute the smart contract. So blockchains are not entirely free, but maybe they are so in some context they are less cheaper to compare the transaction as compared to centralized systems. But in blockchain you also need like infrastructure, new infrastructure that of course like it is itself is expensive as compared to the current working centralized systems. Blockchain can be used for anything. Again, this myth is completely wrong. This statement we can say like it's not entirely correct, because we explored there are some use cases where you don't need blockchain, and there are some use cases where you need blockchain or you can use blockchain. Another one is blockchain can be the backbone of global economy. Again, we cannot completely ignore the importance of our centralized systems which are currently running, and also they are performing their operations successfully in the current scenario. Of course, there are some security attacks and threats which happen time to time, but still they are working quite well. Blockchain can only be used in the financial sector. Again, it is wrong. I have showed you can use blockchain in the healthcare domain, in supply chain, in Internet of Things, as well as you can use blockchain as a security layer, which we will explore in our upcoming lectures as well. Blockchain technology is not ready for business adoption. Again, this one is wrong. This statement is wrong. There are several applications which are already built, and the business adopted those applications, and they are running well. For example, like there are use cases in Estonia as well. Smart contracts have the same legal value as regular contracts, so it is it's not correct, because smart contracts are piece of code that is deployed on blockchains, and they have some conditions. In simple terms, we can say like if-else conditions, and those conditions have to be met to perform the transactions, but they cannot be compared with the legal contracts. So in summary, in this lecture we discussed blockchain, and we explored different blockchain components and the blockchain characteristics, and these blockchain components and characteristics are bringing the new technology and the new concept within different applications domain to build the decentralized applications. We also explored blockchain usage, where we check there was some eCash prediction which was 10 years ago, and also there are some concepts which are emerging within blockchain or decentralized applications, for example like Web3. And also we explored different blockchain use cases, like in blockchain can be used in healthcare, in the Internet of Things, in supply chain, in finance, as a cryptocurrencies, as like non-fungible tokens, in DeFi, SeFi. So these concepts we discussed today in today's lecture. And also we explored different myths about blockchain which are currently circulating in the market. So after completing this lecture, now you can tell with a confidence like what is blockchain, what are blockchain components, and what are blockchain characteristics, and what is the blockchain usage, or what type of use cases we can bring to the blockchain, and what type of use cases are not required to be used or to use the concept of blockchain. And also you can explain different statements related to blockchain, Bitcoin, or other cryptocurrencies, and you can differentiate what is blockchain application, what is Bitcoin, and what are other characteristics which are belongs to the blockchain.